Around 4,000 years ago, the people of Babylon knew how to solve a simple 2 by 2 system of linear equations with two unknowns. Around 200 BC, the Chinese published the 9 chapters of the mathematical art. They displayed the ability to solve a 3 by 3 system of equations. The 9 chapters on the mathematical art is a practical handbook of mathematics consisting of 246 problems intended to provide methods to be used to solve everyday problems of engineering, surveying, trade, and taxation. The simple equation of ax plus b equals 0 is an ancient question worked on by people from all walks of life. The power and progress in linear algebra did not come to fruition until the late 17th century. The emergence of the subject came from determinants, values connected to a square matrix, studied by the founder of calculus, Leibniz. Lagrange came out with his work regarding Lagrange multipliers, a way to characterize the maxima and minima multivariate functions. More than 50 years later, Cramer presented his ideas of solving systems of linear equations based on determinants. Interestingly enough, Cramer provided no proof for solving an n-by-n system. Well, thanks to Euler, he brought to light the idea that a system of equations doesn't necessarily have to have a solution. Gee, thanks! No problem! Well, the turn into the 19th century, Gauss introduced a procedure to be used for solving a system of linear equations, which is now summed up in the term Gaussian elimination. This method uses the concepts of combining, swapping, or multiplying rows with each other in order to eliminate variables from certain equations.
In 1848, J.J. Sylvester introduced the term matrix, the Latin word for womb. He used womb because he viewed a matrix as a generator of determinants. In 1855, matrix multiplication or matrix algebra came from the work of Arthur Cayley, which he defined as the matrix of coefficients for the composite transformation T sub 2, T sub 1 is the product of the matrix for T sub 2 times the matrix of T sub 1. Cayley's work dealing with matrix multiplication culminated in his theorem.
It was published in 2 papers.
One in 1850 and the other in 1858.
His works introduced the idea of the identity matrix as well as the inverse of a square matrix. Matrices at the end of 19th century were heavily connected with physics issues. And for mathematicians, more attention was given to vectors as they proved to be basic mathematical elements. For a time, however, interest in a lot of linear algebra slowed until the end of World War II brought the development of computers. Now, instead of having to break down an enormous n-by-n matrix, computers could quickly and accurately solve these systems of linear algebra. With the advancement of technology using the methods of Cayley, Gauss, Leibniz, Euler, and others, determinants and linear algebra moved forward more quickly and more effective. Regardless of the technology, Gaussian elimination still proves to be the best way known to solve a system of linear equations. The influence of linear algebra in the mathematical world is spread widely because it proves an important base to many of the principles and practices.